RBS Basic Research Academy welcomes you in the lecture number 9. In this lecture, we are understanding how to compute the correlation coefficient of the correlation in the Jamovi. Dear friends, uh, correlation is being used mostly by the every researcher because it's a much more popular technique in the statistics. So whenever we apply any type of the test, now it may be a regression, it may be statistical equation modeling, but it is necessary to compute the correlation of coefficient before applying all these techniques in order to check out the relationship, either the sufficient relationship is available among all the variables in which on which you are working or not. So that's why that's very important technique. Although you can also compute this technique almost in every statistical software, especially when if we talk about the species, we can also compute over there. But the Jamovi has its own advantages to compute it. So what if the advantages are there? So now we are understanding in the Jamui, but before this one, I would also like to give some concepts of the like the correlation because it's very necessary to understand the concepts. So before understanding the concept, I would like to mention myself. My name is Dr. Imber Sumbro and I'm from Shabdi University. So let's go to understand some concepts of the correlation. For this purpose, I have a very wonderful website. It is about the Kent State University website. So here it's written here the Pearson correlation. So I would like to tell you that there are three types of the correlations are there. The first one is a Pearson correlation, and another is a Spearman correlation, and third one is a Candle-Stokes. So I will discuss about this one. But first of all, because mostly people are using the Pearson correlation. 90%, 95% people are using this Pearson correlation. So that's why everyone's talking about the Pearson correlation. And rarely the people are talking about the Candle-Stokes or range or the Spearman correlation. Okay. So now the bivariate correlation produce a sample of the correlation. Okay. So which we normally show with the help of the R. So R is a symbol of the correlation, which means now what we are going to measure over there. So first of all, it's a bivariate Pearson correlation. Bivariate means when are the two variables. So normally we check the relationship between the two variables in the correlation. No matter whatever the variables are, but always we are checking the relationship between the two variables. So now what it measures the strength and the direction of the relationship. So now it's important that there should be a relationship among the data. So now so after that we can apply the Pearson correlation. So in order to check the strength as well as the direction of relationship, we apply Pearson correlation. So whenever we are going to apply the Pearson correlation, it is necessary to have the continuous variable. Okay, and then the Pearson correlation is the name of this one. Alternatively, we can also call it the Pearson product moment correlation. Common uses are there. There are some common uses are the correlation among the pairs of the variable and the correlation within within and the between the variable of some variables are there. So now what it basically does with your data. So bivariate correlation indicate the three things. The first thing is the statistically significant relationship. So first it measures the significance of your relationship. There either the relationship between the two continuous variable is significant or not significant. Another thing it measures there's about the strength of the relationship. How up to what level there is a relationship between the two variables. Either they are perfectly related with each other or somehow there's any relationship like the 0.5, 0.4, 0.3 like this one. And another is the direction. So now either one is either both are increasing like the variable are increasing or both are decreasing or one increase or the decrease. So three things it is showing to you whenever you are going to apply the correlation. Three things: significance, strength of relationship, in the direction of relationship. So again, I would like to tell you the correlation is basically a parametric test. So so now that's why it has to follow some like the parameters. So first one is that two or more continuous variable, maybe at least at minimum there should be the two variable. So now interval are ratio, and then cases must have not missing value. There should not be missing value. There should be a linear relationship between the two variables. And in interdependence cases, the cases should be interdependent from each other. If you have watched out my last video, there's about the paired sample t-test. So now the data where we are collecting from the same subject before and after, so that's why the data depends on another one. So there's a dependency here, there is no independency. Then the bivariate normally, that means the data should be normally distributed and there should not be any skewness, and the data should be collected randomly from the population, and lastly no outliers. And then hypotheses are there, so two-tailed hypothesis is there and one-tailed hypothesis is also there. So now this is the formula. If you want to compute or understand the basic concept of the correlation, then this formula is available here. So basically this R, as already I told you, the R is a symbol of the a correlation. And then if you talk about the strength can be shown with the, when there is a relationship between the two variable is a negative one, it means that perfectly negative relationship is there. If there is a positive one, it means that both variables are positively related with each other. And when there is a zero, that means there is no any relationship at all. And now you're looking here in this one, there is no any zero. So now there is a positive relationship and there is a negative relationship. And then talk about the like the values, that means the 0.1 to 0.3. Whenever there is a 0.1 to 0.3, now it is called is a small or weak correlation. Alternatively, we can say that whenever there is the like the from 1 to 30%, if there's a relationship with the from 1 to 30% relationship is there, but it is a small or weak relationship between the two variables in case of the correlation. But if the correlation value is from the 0.3 to 0.5, it means there is a medium or moderate correlation. And alternatively, we can say if there is a relationship between the two variables is from the 30% to 50%, it is a medium or moderate. And lastly, whenever there is a correlation from the value of the correlation is point from the 0.5 above 0.5, we can say that there is a there is a large or strong correlation. Alternatively, we can say that the 50%, if there is a value is a 50 or more, then there is a strong or like a large correlation is there. But commonly we can say that whenever there is a relationship, the value of the correlation between the two variables is from the 0.3 to 0.8, then you must be happy because there is a very good correlation value is there. But if it is higher than 0.8, then somewhat you'll be worried, and especially you should be worried whenever the value is 0.9 and above. It means there is a one singularity, or it means there is a collinearity between your two variables. If you go into the frequencies of this one, you will check that most of the observations are same. So after attaching the data file with the Jamovi, now you are looking here, the different variables are there. All these variables are there, and there are also some cases are also there. So now how to apply the correlation? So normally when we talk about the correlation, we also talk about the regression. So now, so that's why looking here, regression, there is a one technique, correlation matrix. So some wonders are there really in the Jamovi. So now that's why the Jamovi stands different from the other softwares. Now what these are the good things are, I'm going to show you all these ones. For example, there's a one construct, quality of physical environment. There are the four items or questions are there. Just select all these and ship all these. Whenever you are shipping, you are instantly you are getting the results. In the other softwares, you may not get, except the, I think except your Excel. Excel also providing instant results over there. Okay. So now a few things are there which I want to show. So here we have got some results. But before understanding this table, I want to say something. This is Pearson. So as already I told you, 90% people are using Pearson, but alternatively, Spearman correlation is also there. So Spearman correlation normally we apply when we have the ordinal or ranked data, and candle star we can apply in case of the Spearman, but when the sample size is very small. For example, if the sample size is less than 50, then instead of applying the Spearman, quantity star test is a good option over there. So now our data is not ranked, so that's why we are applying the Pearson correlation over here. And then hypothesis. So now this is whenever you have the hypothesis. Now when you have the two-tailed hypothesis, then this you have to check. And when there's a like the a one-tailed hypothesis, then either positive relationship if you want to check, then you should check this one, or if the negative correlation, then choose this one. But we have the two-tailed hypothesis, so that's why we have to check this one. Okay, some more things are there. Report significance. So now you are looking here, the significance values are there. If you do not report it, then just a simple correlation matrix you are looking here. So, but if you want to have significance, then you just click it. Then the significance values are also there. For example, QPE1 and QPE1, there's a relationship, perfect relationship is there. So that's why there is no need to put any one. Okay, and then we have to check the relationship between the QPE1 and QPE2. That's why so now at one time we are checking the relationship between the two variables. That's why we call it a bivariate correlation. So now the relationship between these two one is at 0.265. It means the 26.5% there is relationship between the uh, QPE1 and QPE2, and this is the positive relationship. So now if we check out this one with our uh, like the criteria, then it's belonging to the weak category because it is less than zero point 0.3. And if we talk about the p value, it is significant because its value is less than zero point 0.5. So now the relationship is weak, but it is a significant. So here relationship is moderate because it is between the zero point 0.3 to zero point 0.5. So that's why we should say it's a moderate relationship, and as well as is also a significant relationship between these two one. And another one is a 0.299, and then again QPE3 and the QPE4, there's a relationship of the 0.39. Again, it's a moderate relationship between the QPE4 and QPE3. Again, it's a significant. So now another thing is the significant leg correlations. So those which are significant, those have been flagged right now. So now there are three stars are there. When the three stars are there, it means the probability p value is less than even 0.001. So now here you're looking is a p value is less than 0.001. So that's why three stars are there. But if you find two star, then the if its value is less than 0.01, alternatively we can say the 90% confidence interval. So here 95% confidence interval is there when there is a zero point 0.5 less than 0.5. So now one static. And then if you want to have the number of the observations, so n is a 257, n is a 257. Confidence interval, if you want to measure, then you will get the lower and upper confidence interval. So now we are not in, and if you want to have a correlation matrix, then these graphs are also there. So these graphs are showing you the relationship between the two variables. So I think that's why it's a wonderful, really wonderful. This software is there where almost everything you are getting within within a few seconds. So now we are unchecking all these things. We are trying to add some more data variables in this one. Okay, QPE3, okay, FQ. Now select this one and move all these one up to here. Now you're looking a very big table is there. So now it is computing right now. Now, but quickly the things have been computed. So now you have a look of all these one. So now if you uncheck this one, then you have a quite a very simple like the table is there. Now see here, the very simple table is there. So now if you add more things, so now the table will become bigger and bigger. So now the table is much more bigger because it is computing. Okay, everything has been computed very quickly. And if you want to compute the graph, you can also compute the graph of all these things. So now the process is in the progress. So now our plots have been computed, but they are looking very tedious to understand because so many variables are there. So okay, so that's why we are unchecking it. Okay, and then we are also reducing the numbers from here. Okay, so now our table becomes very simple to understand. Okay, so now one more thing here that you're looking data on this side and on this side. Normally, if you look at the table of the correlation, as you're looking here, table of the correlation, you're looking at the on the both side, vertically and horizontally, you are finding the same variables are over there. So instead of these lines, there's a one like you're looking here. So now, if you compute this one in the SPSS, you will get the numbers on the both sides. So now then you are required to delete either these numbers or these numbers. So it's tedious work. So for this purpose, you may be required to copy this table and then go open your Excel, put paste over there, and then delete the numbers from the one side, and then so now it is tedious work. So now this problem has been solved by the Jamovi. That's the magic of the Jamovi. So just what you can just click and copy it, and then you can put anywhere where you want. So now these are some of the good things of the Jamovi. Now the same thing we are going to perform in the species. So now the same file is there. Okay. So now just what go into the bivariate and the few things we are going to compute. Okay, and then okay. So now you're looking here, almost the same things are there. So now the relationship between QPE1 and QPE2, 2.65, 4.31, 2.99, you are finding the same results are there. There's no any difference between the results of the species and the results of the Jamovi. But even though Jamovi providing you more facilities, now further if you put now here, so now if you copy this one, now you're looking here on this one. On this side, the same values are there. On this side, the same values are there. So now you are required to edit it, delete these these observations or delete this observation. Okay, and one more thing, you have also delete the significance and aim. So now, but these things are there. So just you can if you want to insert these things, you can also, otherwise you can delete it and just copy and paste anywhere. So these are some of the facilities which are being given to the Jamovi. So that's why Jamovi is much more powerful and advanced than the SPC, because it's an open source. So many developers are working on the Jamovi. So every day they are adding some more things in the Jamovi. So that's why Jamovi is a Jamovi. So thank you very much for watching this video to the end of this video. I hope you like this video. If you like this video, kindly share this video, comment on this one, and please subscribe my channel. Thank you very much.